Welcome to this session on designing a course and constructing a syllabus. In this session, we'll first have an introduction to the session, then discuss the components of a syllabus, backward course design, course content prioritization, and learning objectives. Traditional course design starts with a list of topics that the instructor would like to teach, without a framework to tie the topics together. This leads to rote memorization of course material without truly understanding it. As a result, in traditional courses, students acquire knowledge without a framework to tie material together, making it difficult for students to deeply understand the material. In addition, learning is not very rewarding, and it is hard to generalize and apply knowledge to new situations. By structuring your course to focus on big ideas and helping students to construct mental frameworks, we can increase student retention and improve our students' ability to transfer knowledge. Knowledge is not equal to understanding. If knowledge is facts, then understanding refers to the meaning of those facts, the insights into the essential material to be able to transfer knowledge. This quote signifies the difference between knowledge and understanding. What differentiates revolutionary thinkers from non-revolutionary ones is almost never a greater knowledge of the facts. Darwin knew far less about the various species he collected on the Beagle voyage than did experts back in England who classified these organisms for him. Yet expert after expert missed the revolutionary significance of what Darwin collected, who knew less but somehow understood more. Charles Darwin was able to transfer his knowledge of individual species to understand the importance of his discoveries. His findings helped him formulate the theory of evolution. Let's go through an example. Here we have a math question from a standardized test for high school students in the United States. This question demonstrates a situation in which we can help students learn material more effectively. The question is, what is the distance between the points 2, 10 and -4, 2 on the xy plane? A, 6, B, 8, C, 10, D, 14, or E, 18? Pause the video here to answer the question. In this problem, students are asked to apply their knowledge of the Pythagorean theorem to this situation where they are asked to measure the distance between 2 points, which make up the hypotenuse of a right triangle. In this case, the length of one side of the triangle is 6, and the other side is 8. Let's plug the numbers into the equation to solve for the length of the hypotenuse, c. The Pythagorean theorem can be expressed as a squared plus b squared equals c squared. In this situation, once we plug in the numbers, we get 6 squared plus 8 squared equals c squared. Evaluating the expression means that c equals 10, which corresponds to answer choice C. Only 33% of students were able to solve this problem correctly. This was the hardest problem on the standardized math test, because students couldn't apply their knowledge of the Pythagorean theorem to a new situation. The goal of this session is to illustrate how backward course design can lead to a more effective course that aids in understanding and transfer. The learning objectives are that by the end of the session, you will have considered ways to 1. State the components of a syllabus. 2. Identify the components of backward course design. 3. Evaluate content for a course you would like to teach based on content priorities. And 4. Define and develop learning objectives for a course you would like to teach. We're going to talk about the syllabus first, because it's often the first thing that a student will receive in a course. Then we'll discuss how to design an effective course in further detail. A syllabus is essentially a roadmap for your course. It describes where you are going during the course, your reasons for going the way that you are, and how you are going to get there. A syllabus also serves as a contract between the instructor or instructors and the students. It is an explicit contract in that it documents all of the necessary course details and policies. It also serves as an implicit contract because it sets the stage for instructors' teaching style and what is expected of the students in the course. Professor Michael Schaefer at Rutgers University states, "A good syllabus is evidence that you have devoted the essential effort needed to create a good course. A bad syllabus is students' first warning that you haven't, and that your course is likely to disappoint." This quote signifies the importance of a syllabus in providing evidence for students that their instructor has sufficiently prepared the course. A syllabus is especially important if your course is an elective course. Students may make decisions on whether they will take your course based on your syllabus. Now we'll talk about the components that are at the core of a syllabus's explicit contract. First, the syllabus should contain basic course information, such as the course title, meeting times and locations, course website, and information about the course instructor and any teaching assistants, including their name and contact information. Oftentimes, the syllabus is just a list of topics that will be covered during the course, and this is unenlightening. The syllabus should contain a description of the course, including the big idea or ideas of the course. And it should include a statement about the overall course goals and objectives. These are included in a well-designed syllabus to indicate the concepts that students should know or be able to do by the end of the course. This helps to address the question of, where are you going in the course? Information on course assessments, including their number and type, as well as specific grading information, is also included in a syllabus to indicate how you will know if students have achieved the course's learning objectives. A syllabus should also include a lecture schedule or a complete course calendar. And it should include descriptions of the instructor's policies, clearly defining for students if they can collaborate with others, what happens if they cheat, and how they can make up missed exams. Let's take a look at an example syllabus. The example syllabus that I will be using can be accessed on the course website. The syllabus contains the course title and course number, as well as the semester in which it is being implemented. The course meeting times and locations are listed at the top of the syllabus, along with the instructor's name, contact information, and office hours. Then the syllabus contains a description of the course. Notice that this describes the impetus for creating the course and the big ideas of the course. The description also contains reasons for including specific learning techniques in the class. The instructor has also written learning objectives that clearly state the skills, knowledge, and attributes that the student should have by the end of the course. The syllabus lays the foundation for the instructor's expectations for the students, which represents the course's implicit contract. The necessary texts and materials are included in the syllabus, along with information regarding the assessment methods, which includes information about the types of assignments and grading. Lastly, the syllabus contains a lecture and assignment schedule. This is an example of an effective syllabus that presents all of the necessary components of a syllabus. It clearly demonstrates to students in the course that the instructor has devoted the necessary time to design an effective course. If you would like to look at the syllabus in more detail, it is available on the course website. Let's talk about the components of your syllabus that serve to define the implicit contract. The syllabus serves as an example of your teaching style and sets the stage for your expectations of your students. But remember, your teaching style in the classroom, which active learning techniques you use, and how you respond to your students in class will set the stage for how your students will learn. Answering these example questions here will help you establish the norms for your classroom. For example, who talks in the classroom? When do they talk, and for how long? Is the instructor the only person to talk in your classroom, Or is your course an interactive discussion course? How strict are your assignment deadlines? Do you allow late submissions? How are students expected to act in the classroom? Is there a hierarchical relationship between the instructor and student, or is it collaborative in nature? And how are students expected to interact with each other? Are students allowed to collaborate with one another? The answers to these questions and others will set the stage for learning in your course. Creating a syllabus, once the course is designed, is the easy part. For the remainder of the session, we will discuss how to design each of the components of a course that are reflected in the syllabus. We're going to talk about a particular strategy called backward design that is used to create courses that help students better understand the course material and gain the ability to transfer their knowledge to new situations. The backward design process can help you deliver a more effective course by minimizing rote memorization and maximizing transfer of knowledge. In backward design, start with a list of the most important concepts that students should know, be able to do, and understand by the end of the course. This refers to the course learning objectives, or our intended goals for students to achieve by the end of the course. From here, you can develop the assessment methods that will help you best determine whether students have reached your learning objectives. The assessment tools will comprise the assignments and exams in your course. The last step of the backward design process is to plan the learning experiences and instructional methods that you will use to help your students reach the intended learning objectives. This process of backward course design will help you effectively design a course to enable transfer of knowledge. Let's go through each of the stages of the backward design process in more detail. The first step of the backward design process is to identify the goals of your course, and then you can design everything after that: the learning objectives, assessment tasks, and then the instructional experiences. When you are determining the goals of your course, think about your students' skills, knowledge, and attitudes. In the second step of backward design, determine the acceptable evidence for students having met the desired learning objectives. The assessments that you choose should be performed at both the beginning of and throughout the course. In the third step of backward design, you will design the in-class activities and instructional methods to create the necessary learning experiences to help your students meet your learning objectives. Before you begin thinking about learning objectives, you must prioritize the content for your course. This exercise will lead into the development of the learning objectives. When prioritizing the content for your course, start with the big ideas and core tasks that you would like your students to have by the end of the course. Big ideas are the enduring understanding that connects concepts throughout the course. They are the glue that holds everything together. Big ideas are broad and abstract, universal in application, apply to many examples. When you are planning the course, ask yourself the following questions. First, what understanding about big ideas should students leave with? And second, how do common misconceptions inform your selection of desired understanding? A big idea can be a word, phrase, sentence, or question. Examples of big ideas from the Wiggins and McTee reading are evolution and hunter-gatherer societies. One place to find big ideas are in state or national educational standards. Thinking about the big ideas for your course is very difficult and may take teaching the course more than once to help you identify the big ideas. Then ask yourself about what you would like your students to know and be able to do by the end of the course. This second circle corresponds to your learning objectives, which represent the skills, knowledge, and attitudes that you would like your students to obtain in order to be able to transfer knowledge successfully. Lastly, include content that you would like your students to be familiar with by the end of the course. For example, this may be the names of historical figures, important dates, or formulas. All of the other content that doesn't fall into one of these three circles probably shouldn't be included in your course. Once the content is prioritized for your course, as the instructor, you can adjust the assessments and instructional activities appropriately to align with your prioritized content. Now you'll have a chance to brainstorm the big ideas in your discipline. What are the big ideas within your discipline? If possible, work with at least one other person from a similar discipline and then share your big ideas on the online course forum. Pause the video here while you complete the activity. Now that you've had a chance to brainstorm your ideas on your discipline's big ideas, I will share a few example big ideas for several different disciplines. One big idea in physics is energy conservation, meaning that energy is conserved and is minimized at equilibrium, although it is subject to relevant constraints. In biology, evolutionary mechanisms is a big idea. This big idea is about how natural selection produces evolutionary change, and random effects can affect evolutionary history. In chemistry, the big idea of the relationship between structure and function is about how the structure of molecules determines its function and role. In mathematics, the big idea of divide and conquer can describe integrals and derivatives. When taking the integral of derivative, you utilize small intervals in which hardly any change is observed. Then, when taking the integral, you add up neighboring pieces. And while taking the derivative, you divide all of the pieces. In systems, the big idea of feedback loops focuses on the fact that systems interact with other systems via forces, messages, or in general, via information or signals. Even though the big ideas listed here are only listed for one discipline, they are frequently interdisciplinary in nature. For example, the relationship between structure and function is relevant to biology as well, in that by understanding a protein structure, you can understand its function. In addition, feedback loops are also relevant to biological regulatory networks. In this activity, you will have the opportunity to prioritize content for a course that you teach or would like to teach. First, work on your own and identify the underlying concepts in the list of topics that you generated as part of the pre-session assignment. Then prioritize the content into the categories of content prioritization: the big ideas and core tasks, important to know and do, and then the worth being familiar with. Once you prioritize the content for your course, work with one other person to share and refine your content prioritization. Pause the video now to complete the activity. Now that you've had a chance to complete 2 activities to brainstorm big ideas and prioritize content, let's have a discussion on the pre-session readings. The pre-session readings were chapters 1 and 2 on clarifying content priorities and backward course design in the book titled Understanding by Design by Wiggins and McTee, and the second reading was a resource on Bloom's taxonomy. What were your reactions to the readings? Do you have any questions about the readings? Pause the video here while you first post your reactions and questions on the online course discussion forum, and second, respond to your peers' reactions and questions. Now we're going to talk about designing course learning objectives. The SKA scheme can help define the learning objectives for your course by thinking about the skills, knowledge, and attitudes that you would like your students to attain by the end of your course. Think about the answers to the following 3 questions. What should your students be able to do? What should students know and understand? And what attitudes or attributes should students have? One example of an attitude or attribute is the level of confidence of your students in their ability to perform a skill. Now we're going to talk about learning objectives. Learning objectives are statements that serve to describe a specific, observable, and measurable student behavior. They include a verb that describes the observable and measurable action, and should also include a description of the conditions under which the action takes place. For example, the learning objective may begin with the phrase, "By the end of the class session, you should be able to." In addition, a learning objective should clearly indicate what will be accepted as evidence that learning took place. Learning objectives are not simply a list of topics to be covered. Instead, learning objectives should focus on the concepts, which encompass many topics. For example, in biology, a concept is that a cell is created from other cells. But the topics that would be covered in the course include the cell cycle and meiosis, amongst others. And learning objectives are simply not a list of actions to be performed by the instructor. Instead, learning objectives focus on the knowledge and skills that the student should be able to attain by the end of the course. Lastly, learning objectives are not the list of your hopes and expectations for the course, but are rather measurable, observable, and specific statements about your goals for the students. The goal of writing and providing learning objectives is to, first, help students understand what they should learn and focus on the important material. Second, help faculty decide what content to teach to best support the learning outcome. And third, dictate what the assessment should be. Course learning objectives should address a range of cognitive abilities. Benjamin Bloom performed seminal education research in the mid-20th century. His primary goal was to create a framework of educational objectives to be able to categorize educational materials by their cognitive level. This categorization process by teachers from many different schools would enable easier sharing of materials that require similar cognitive abilities. Bloom published the original taxonomy in 1956, and then it was revised in 2001. In this class, we will use the revised Bloom's taxonomy. The revised Bloom's taxonomy contains 6 levels, ranging from lower cognitive abilities such as remember and understand, to higher cognitive abilities of evaluating and creating. Remember refers to the ability to recognize and recall information. Understand is the ability to explain, interpret, and infer ideas of concepts. Apply is the ability to use the information in another way. When students analyze, they are able to break information into parts to explore understandings and relationships. When students evaluate, they are able to justify a decision or course of action. In the highest cognitive level, create, students generate new ideas, products, or ways of viewing things. When writing learning objectives, use concrete action words that clearly tell the student what they should be able to know and do. Let's go through examples of strong active verbs for each of the levels of Bloom's taxonomy. The verbs recognize, list, describe, identify, and name can be used for learning objectives at the remember level. Explain, summarize, and classify can be used for the understand level learning objectives. Use, carry out, execute, apply, and implement can be used for apply learning objectives. Compare and differentiate can be used for analyze level learning objectives. Critique and judge can be used for the evaluate level. And design, construct, plan, and produce can be used for create level learning objectives. A more complete list of action verbs is on the provided Bloom's taxonomy handout. When writing course learning objectives, it's important to address all cognitive levels, and it's important not to merely use these words, but to also take into consideration the level of cognitive ability at which you are designing the course. For example, you may be teaching an introductory level course, but you can still ask the students to apply, analyze, evaluate, and create, but might use less complex situations and problems than you would use in a graduate level course. Now let's go through the process of rewriting a learning objective on Euler's method. Euler's method is a method to solve ordinary differential equations. Understanding Euler's method is a stepping stone to understanding more complex ways of solving differential equations. While some may argue that Euler's method is a topic, not a concept, there are many mathematicians that do refer to it as a concept. The first learning objective is, students will gain an understanding of Euler's method. Is this learning objective observable, specific, and measurable? Pause the video here while you think about the answers. This learning objective is observable in that students will realistically be able to meet this learning objective by the end of the course. However, it isn't specific. For example, in what context would the instructor like the students to be able to understand Euler's method? In addition, it isn't measurable. A student can't tell how a gain in understanding will be assessed. And as a result, we recommend that you do not use the verb understand when writing learning objectives. This learning objective has been rewritten, and now it reads, students will be able to use Euler's method to solve ordinary differential equations. Is this learning objective observable, specific, and measurable? Pause the video here while you think about the answers. This learning objective is observable. It's realistic within the framework of the course. It is specific because the context of differential equations is provided. And it's measurable because students know that they should be able to use Euler's method. This learning objective corresponds to the apply level of Bloom's taxonomy. If the instructor would like the learning objective to reflect a higher cognitive level, then it can be rewritten to say, students will be able to describe the rationale for the use of Euler's method over other ways to solve ordinary differential equations. In this case, the learning objective is asking students to be able to rationalize the use of Euler's method over other methods of solving differential equations. Is this learning objective observable, specific, and measurable? Pause the video here while you think about the answers. This learning objective is observable because it's realistic within the course. Specific because the context of the differential equations is provided. And it's measurable. Students know that they should be able to rationalize their use of a particular method. Now it's your turn to write learning objectives for your course or a course you would like to teach. Work on your own to identify the underlying concepts and skills and write learning objectives for your course. Then work with one other person from a similar discipline to share your learning objectives and refine them. When creating your learning objectives, make sure that each learning objective covers a concept and not a topic that is disguised as a concept. In addition, be sure to write down your learning objectives as they can be used to complete the post-session assignment. Pause the video now while you complete this activity. Now we will go through the revision process of learning objectives using two examples. These learning objectives are from an example lesson plan on teaching statistical analyses and experimental variation in an introductory genetics course. These two examples demonstrate the revision process that is needed to ensure that the learning objectives are observable, specific, and measurable. The first example is, by the end of the course, you should be able to explain the effect of sample size. Is this learning objective observable, specific, and measurable? Pause the video here while you think about the answer. This learning objective is observable and measurable, but it is not specific. The context in which students should be able to explain the effect of sample size is not clarified. In the next draft, the learning objective states, Explain the effect of sample size on the observed phenotypic ratios and corresponding genotypic ratios. This learning objective is now specific because it is very clear that students should be able to explain the learning objective in the context of phenotypic and genotypic ratios. This learning objective is now observable, specific, and measurable. Through this revision process, we realized that we would really like students to reach a higher cognitive level of thinking with this objective. But this was not reflected with the verb explain, which is in the understand level of Bloom's taxonomy. As a result, we rewrote this learning objective one more time. The learning objective now reads, compare and assess the effect of sample size on the difference between observed and expected phenotypic ratios. This learning objective is observable, specific, and measurable. This learning objective is now a Level 4 learning objective, which corresponds to the analyzed level in Bloom's taxonomy. Now let's revise another learning objective for our lesson plan on statistical analyses. Explain why you would use a chi-square test and how it can be used to reject a hypothesis. This learning objective is observable and measurable, but it is not specific. The context for using the chi-square test is not clear. To make this learning objective observable, measurable, and specific, it was rewritten. Describe how the chi-square statistical test is used to determine the probability that the observed data lend support to the null hypothesis. This rewritten learning objective is now specific because it indicates to students the context in which the chi-square test will be used to determine whether their experimental data lend support to their hypothesis. Now that we have gone through the process of rewriting two different learning objectives, I hope you'll be able to use this process to help yourself write learning objectives that are observable, specific, and measurable. In this session, we discussed the components of a well-written syllabus and effective course design using the backward design process, content prioritization, and learning objectives to focus on increasing student understanding and students' ability to transfer knowledge to new situations. Do you have any questions or comments? Take a moment to write any lingering questions or comments that you may have on the discussion forum. The post-session assignment for this session is to create 5 to 10 learning objectives for a course that you teach or would like to teach. Make sure that your learning objectives are observable, specific, and measurable. Please see the instructions on the course website for information regarding the submission of your assignment. Immediately following your viewing of this session, please follow the link to the online survey for the mud card.